Hi, good afternoon. So, Happy New Year. Uh, today we're going to discuss the introductory chapter of Levenspiel. Ano? So, supposed to be, we have two standard references for chemical reaction engineering. Levenspiel and Pagler. Ano? So, we'll start with Levenspiel. Ito kasi standard. And then, yung Pagler kasi it's the modern textbook, ano? Medyo mas bago 'yon. Pero as you can see, this is ang Levenspiel parang introductory theoretical ganun, ano? Tapos yung Pagler naman, that's the parang yun yung practical, ano? So we'll discuss first the basic, and then sana may oras pa, we'll proceed with Pagler. So I'm recording this session, tapos I'm going to share my PowerPoint. Okay, so this is the author of the book, ano? Si Levenspiel. Octave Levenspiel. Si Spider-Man lang, ano? Alam niyo pa ba si Octavius? So the chapter 1 is overview of chemical reaction engineering. So in this particular chapter, we were just going to calculate the rate of the reaction in its standard unit, yung mole per cubic meter per second, so that we can compare the speed of each type of reaction. Okay. Let's proceed. So generally, pag meron tayong chemical plant, no, the general process is you have raw material, then it will undergo physical process, no. Halimbawa, dry nyo, tataasan nyo yung temperature, tataasan nyo yung pressure, no. So you have pumps, you have heaters, ganun, no. Kaya bababaan nyo yung temperature, you have coolers, you have compressors para tumaas din yung pressure pag gases, no? And then after that, this raw material will go to the reactors. So kaya nga chemical plants, ano, generally pag chemical plants, yung heart talaga nun ay yung reactors. So itong course na to is really for the design of the reactors, no? So yun, susunod is the chemical treatment steps. This generally refers to the reactors, no? Tapos after the reactors, pupunta yun sa mga physical treatment steps. Yung mga physical treatment steps naman, usually this will produce the pure products. So dyan yung distillation, hindi pa natin naabot sa ano, no? So sa SEP, distillation, liquid extraction. Generally, pag purification talaga, distillation yan, no? Mga ganun. Pag-aaralan nyo pa yan. Alam nyo naman yan, we have 21 unit operations, ano? So, generally, isa yun sa 21 na unit operations. And then we have the product. So, sometimes may mga recycle, kasi may mga raw mats pa na natitira, sineseparate dun sa product. So, that's why nire-recycle, ano? Pag nag-Aspen HYSYS, no? Computer application, makikita niyo yung mga recycle na yun. Kung paano magdudugtong-dugtong yung pumps, tapos pupunta sa reactor, tapos meron kayong distillation, tapos magre-recycle kayo. Makikita niyo yun sa 134, sa 184L pala. Computer application chemical engineering. Anyway, let's proceed. So, the performance equation. So, ang pag-aaralan natin dito sa sa chemical reaction engineering is we need to predict kung ano yung magiging output No, halimbawa given yung input, given yung concentration niya, given yung amount niya, given kung what kind of chemicals yung pumapasok sa reactor, kung ano yung temperature sa loob ng reactor, kung ano yung pressure sa loob ng reactor, kung anong meron sa reactor, halimbawa may catalyst o wala, we should be able to predict the output, no? So kung mabilis yung reaction, probably the equilibrium, no, will tell us what will happen. Nakuha natin yan sa ano, 'di ba? Sa solution thermodynamics, ano? 'Di ba? Pag mabilis yung reaction, equilibrium yung gagamitin natin. Pero pag relatively mabagal, karamihan nung tinitake up nating reaction dito sa ano sa chemical reaction engineering, medyo mabagal yung reaction. So kinetics naman, ano, yung gagamitin natin. And then yung contacting pattern, yung dito kasi sa course na to, generally dalawa lang siguro yung makukuha natin, yung PSTR, okay, at saka yung PFR. So hindi ko alam kung maabot natin yung mga may catalyst, ano, o yung mga heterogeneous reactor, yung mga PBR. Subukan natin. So dito sa contacting pattern, generally dalawa lang yan. Yung isa, yung CSTR, so parang may tangke lang tayo. Yung CSTR, so continuously stirred tank reactor. So meron lang tayong tangke, tapos papasok dito yung feed. Dito sa loob generally sa loob ng reactor merong agitator, no? Merong mixer. Number 8. Yan. May mixer dyan, sa mixer, no? Tapos mag-overflow lang yung product. So lalabas lang dito yung product. So ito yung product. Ano? Ito yung reactant, tapos ito yung product. Usually CSTR is used for liquids, ano? Siyempre pag gas yan, hindi ka gagamit ng CSTR. So maghahalo ka ba ng hangin, ano? So siyempre hindi ka pwedeng maghalo ng hangin. It's not practical kasi halo na agad 'yun pag gas, ano? Generally pag liquid yung CSTR. So the other type of the reactor is yung PFR. PFR is plug flow reactor. Usually parang pipes lang 'yan, mahaba. So walang agitator 'yan. Mapapasok lang dito yung reactant nyo, tapos pagdating doon sa dulo, you will have your product. So ito yung dalawang contacting pattern na probably madidiscuss natin dito sa chemical reaction engineering. Ano yung CSTR at PFR. So hindi ko alam dati, alam ko wala na kayong 172, ano? Parang kinumbine na sa 171T. Kasi 5 units na to eh. No, yung count sa amin 5 units na siya. So dati nung may 172 pa, doon namin kinukuha yung PBR. Yung PBR naman, yung this reactor, yung may bed reactor, may catalyst to sa loob. Pwede siyang, generally parang PFR siya, ano, pero may screen lang sa dalawang side, tapos naka-embed yung catalyst sa loob. So, basta may catalyst siya sa loob. Ano? It could be several beds of pipes, parang ganyan. Several beds of pipes. Dito papasok yung, or several banks of pipes, ano? Tapos dito papasok yung reactant. Tapos dito sa loob merong catalyst. Actually, this is the most common type of reactor, itong PBR. Kasi karamihan ng reaction may catalyst, ano? So that's what it's meant by contacting pattern on how material flow through and contact each other in the reactor. So as you can see, iba yung way that they become in contact with CSTR, iba rin sa PFR, iba rin sa PBR, ano? How early or late they mix, their clumpiness or state of aggregation by their very nature. Some materials are very clumpy, for instance, solids and non-coalescing liquid droplets. So yun yung contacting pattern, ano? So CSTR, types of parang types of reactor yun. CSTR, PFR, PBR. Iba-iba rin yung equation for each of these types of reaction. It's quite easy. You will encounter this. We're going to discuss this later. Let's proceed. Parang lang naman to, introduction lang, chapter 1. So these are the types of reaction, or reactor design. So we have homogeneous type of reaction. So most gas phase reaction, non-catalytic at saka catalytic. Katulad yan sinasabi ko sa inyo. So iba kasi yung design ng reactor pag walang catalyst at saka pag may catalyst. Kamukha yung sinasabi ko sa inyo, yung CSTR at saka yung PFR, yun yung non-catalytic, wala siyang catalyst. Ano? So mas simple yon compared to sa may catalyst. So pag may catalyst na, usually PBR na yung tawag doon, packed bed reactors. Ano? So dati kami nung 171, dinidelay namin yung discussion ng PBR sa sa 172. Ngayon sama-sama na tayo, ano? Kasama na yon. Kaya lang ayoko naman kayong guluhin na habang nag-discuss tayo ng CSTR at PFR, sasabay na natin yung PBR. Eh, ang PBR naman, usually ginagamitan siya ng software kasi medyo mahirap siyang imano-mano. Ano? Kasi ano yun, DE na yun, differential equation ng solution pag PBR. Variables. Okay, so yun, pag halimbawa, you have enzymes, no? You're using enzymes. So, yung enzyme, these are catalysts, di ba? So, ang usually ginagamit yan, mga PBR na yan. So, mas complicated yung reactor niya, no? And kasi generally din pati, yung mga reactors, ano yan, patent na yan, no? Maraming klase ng reactor. So, yung dinidiscuss lang natin dito, yung mga basic lang like CSTR, PFR, gano'n, ano? So, kasi pag nag-field trip kayo, makikita nyo, iba't ibang klase talaga yung reactor. Kasi hindi nyo makikita yung loob. So, kanya-kanyang patent yan. Mga trade secret yan. Ano? Hindi. Yung iba nga, hindi nila talaga pinapatent. Kasi pag pinatent mo, nakalagay na yun. Ma-access yan, di ba? Open yan sa internet. Available yun online. Pero kailangan hintayin mo muna, halimbawa, 7 years bago mo paggamitin ng public. And then, aside from, halimbawa, catalytic, non-catalytic, tapos homogeneous, meron ding heterogeneous. So, halimbawa, yung catalyst nyo, solid, pero yung nagre-react, both gases, di ba? So, yun, yung kalagay naman dito yung mga examples. Ano? Yun, halimbawa, itong oxidation of SO2 to SO3. Catalytic yan, ano? May ginagamit silang catalyst. This is, you might be thinking, diba parang napaka-special. This is very common kasi ito yung reaction sa paggawa ng detergent, no? Diba gagawa kayo ng Tide, gagawa kayo ng Breeze, diba? Araw-araw natin ginagamit ang mga detergent pag naglalaba tayo, ano? Ito yung kanyang one of the reactions sa paggawa ng ng detergent, oxidation of SO2 to SO3. Kasi you need SO3 para mag-react dun sa linear alkyl benzene. Hindi pwedeng SO2, mabagal yung reaction mo. Tsaka you're going to produce a good detergent. Di ba? So, you need to produce SO3. Okay. Ammonia synthesis, yan yung sa fertilizer. Di ba? Yung N2 plus H2, you're going to produce NH3. So may catalyst din yan na solid. Ano? Gas, tapos solid. Ito rin, di ba? Gas, tapos solid din yung catalyst. So it's catalytic and heterogeneous. So as you can see, this is beyond the scope of undergraduate chemical reaction engineering. Kasi usually ginagamitan na ito ng mga software. Pero kasi since 5 units siya, probably nandito na rin yung 170. No? Ganun yun. So I will try to taught you how to use polymath pag nag-PBR. Sana maabot natin, ano? Para makapag-solve tayo ng mga ganitong klase ng problems. Okay, so definition of reaction rate. There are several units pag na ginagamit for solving reaction rates, ano? So the first one is based on the volume of liquid. Usually kasi pag volume of liquid in the reactor, pwedeng yun na rin yung volume ng reactor. So yung iba, ito yung ginagamit, no? So that's why this is moles of I form per volume of liquid per unit time. So kung natatandaan nyo doon sa prelims natin, ganito na rin naman yung unit natin. Di ba? Molarity per second. Di ba? Yung molarity kasi, it's moles per liter. So that's why it's almost equivalent to moles of I form per volume of liquid per unit time. Now, tapos second one is based on unit mass of solid in fluid liquid system. So pwedeng per mass of catalyst, yung solid na nire-repair dito. Pwede rin per unit of reactant. Pero usually itong mass of solid dito is yung mass ng catalyst. As you can imagine, yung volume of fluid dito, it also refers dun sa volume ng liquid or fluid dun sa reactor. Kaya parang siya na rin in effect yung volume ng reactor. Effective reactor. Di ba? Na-imagine nyo ba yung sinasabi ko? That's why yung mass ng solid dito, pwedeng this refers to the mass of solid or the mass of catalyst. Parehas lang naman. Ito lang yung pinagkaiba. Volume of fluid, ito mass of solid. Tapos the next one is this is per surface. So kung minsan naman yung mga catalyst in terms of available surface yung ginagamit na unit. No, halimbawa area or surface area, So per surface unit, per area yung ginagamit sa reaction rate. So ang ano lang naman kasi diyan pag nag-plant design na kayo tapos nagbabasa na kayo ng paper. So huwag kayong maso-surprise kung bakit sa 171 palaging volume of reactor lamang yung aming R. Bakit pag nagbabasa na kami ng paper ibang-iba? Ganun lang yun. So nasa introduction naman ni Levenspiel yun na pwedeng iba-iba yung unit ng reaction rate. Pwede siyang per volume of fluid, per mass of solid, per area. Okay? So, siyempre, malaking bagay kasi yung ma-introduce na mayroong ganun. Tapos, relatively, yung solution naman yan, generally, ang dali-dali lang naman eh. Pag halimbawa, pag mass of solid, per mass of catalyst. So basically, kung given yung R, you can easily calculate the weight of the catalyst. Tapos pag meron kayong density ng catalyst, you can easily calculate the volume of the reactor. Ganun lang kadaling mag-design ng reactor. Tapos may mga rule of thumb namang ituturo sa inyo sa equipment design. Halimbawa, twice yung height ng diameter, mga ganun-ganun lang na rule of thumb. So madali lang talagang mag-specify ng dimension ng reactor, So actually, in reality, relatively madali lang naman, Lalo na hindi naman talaga ikaw yung mag-start ng process, meron ka ng reference kung ano yung rate ng reaction. Ito pa yun, pwede ring volume of solid, So pag volume of solid naman yung given na rate of reaction per volume of solid, so diretso na yan, di ba? Mas diretso yan kasi yung kasing mass of solid gagamit ka pa ng density. So pag volume of solid, diretso na yan, You can directly calculate the volume of the reactor using the volume of solid or volume of the catalyst. And then this one is, ito usually yung volume of the reactor. Yung final, volume of the reactor, ito diretso. Okay? I hope na-introduce ko lang sa inyo yung possibility, Yung different possibility ng unit ng reaction rate. So, para pag nagbasa kayo ng mga papers, ng mga journals, pag nagpa-plant design na kayo, kasi ganoon naman talaga, magbabasa kayo ng mga journals para magkaroon kayo ng plant design. So yung makukuha yung mga journals, iba-iba yung unit ng reaction rate. Hindi, usually ito kasi yung unit natin ng reaction rate per volume of reactor. So hindi kayo masyadong mawiwindang, parang gano'n. So pag CSTR third term. Pag CSTR kasi, tulad nung drawing ko sa inyo kanina, meron siyang in, meron siyang meron siyang stream na pumapasok, ang bakit yung CSTR, Meron siyang pumapasok, So, ito yung in. Tapos meron siyang nag-overflow, ito yung out. So pag nag-mass balance tayo dito, usually merong term na in, tapos merong sa second term is the out. Yung third term kasi merong reaction na nangyayari. So that's why we call that the third term. Yung generation term. So pag halimbawa yung unit nyo is per volume of fluid, i-multiply nyo siya ng volume of fluid. Or di ba? Yung RI. Tandaan niyo pa to kasi di ba yung definition natin kaya nung rate of reaction, yung RI volume of fluid per volume of fluid, yung RI prime per mass of solid, yung RI double prime per surface of solid, tapos yung RI triple prime per volume of solid. So Yung third term ng CSTR, ang pamumultiply nyo pag RI, volume of fluid, pag RI prime, volume of solid, etc. etc. No? So, ganun lang yun. Anyway, kung hindi nyo pa masyadong ma-imagine sa ngayon, i-discuss naman natin yung CSTR, I think chapter 2, tapos yung PFR chapter 3, and then it's relatively easy. So, kumbaga, hindi nyo naman kailangan pang maintindihan sa ngayon kung hindi nyo ma-imagine yung sinasabi ko dito. Ano? Basically, what I'm just trying to say is, yung CSTR equation is mass balance, magmo-mole balance lang tayo. That's why yung in, yung first term, yung out, yung second term. Tapos yung third term, yung generation, yung nangyagagaling sa reaction. So ito yung third term niya, no? So yun, BRI, WRI prime, SRI, double prime, BSRI, triple prime, and then BRRI, apat na prime, ano? So introductory chapter lang naman to. And then these are the relative speed of the chemical reaction. So dito tayo magso-solve, ano? So yung mga reaction sa katawan natin, it's relatively slow, ano? Yung mga cellular reactions. Nasa ano siya, 10 to the minus 4. Yan. So-solve tayo ng mga problems, tapos makikita nyo yung unit ng chemical reaction. Ito yung unit na gagamitin natin, ano? Moles of A disappearing per cubic meter of T per second. Ito lang lahat, ano? So yung cellular reaction, yung order niya is 10 to the minus 4. Yan, pag working hard daw, no, busy ka o kaya tumatakbo, medyo tumataas siya, malapit na sa 10 to the negative 2. Yung coal is pag nagsusunog kayo ng coal, ano, nasa 10, no? 10 hanggang 100. sa jet engines, umaabot ng 1,000 yung reaction, medyo mabilis, ano? So sa rocket engines, ano ba kayo, don't look up. Sa rocket engines, nasa 10 to the 4, no? Nakabahan ako sa don't look up, ano? Parang sinasabi nila ganun kadelikado yung fake news, ano? Matter of life and death na. Ipagkakatiwala pa natin sa fake news yung ano natin, ano? Yung picture natin. And then akala ko dito lang nangyayari sa Pilipinas yun. Worldwide pala talaga, ano? Ganun din yung sentiment pala sa, at least sa US, ano? But that's why Maria Ressa win the Nobel Prize kasi ganun talaga ganun yung ano, ganun yung sentiment. It's actually triple threat talaga sa humanity yung nangyayari ngayon, you know? Fake news, tapos andyan pa si COVID, tapos nandiyan pa yung climate change. Grabe. Pero sana makasurvive naman tayo. Ayan, sa rocket engines kasi, di ba kita nyo, kailangan niyang kumawala sa gravity, no? So, 10 to the 4 yung speed ng reaction, mas mabilis, ano? As compared to sa jet engines. Ang jet engines kasi parang combustion din lang yan, eh. Relatively, kasi di ba yung ginagamit na fuel sa plane, tandaan nyo pa ang termo nyo, naabutan nyo pa naman yung jet engines, ano? Tandaan nyo pa? Di ba diniscuss natin ang jet engines sa 1, 2, 3, 2. So, yun, ano lang, 1,000 lang, 1,000 moles of A disappearing per cubic meter per second. And then, there are bimolecular reactions. Every collision counts at about 1 atmosphere and 400 degrees Celsius. So, bimolecular reactions, I don't know what is specific reaction. Ito, ano? Anyway, tingnan na lang natin mamaya sa mga examples. No? Let's try to solve some problems. Basta remember, kasi sa yung ibang problems dito, hindi mention na ito yung unit dapat ng answer. Pero yun, ang purpose natin para i-compare natin yung rate ng reaction. So ito yung gagamitin natin unit. Ano? Moles of A disappearing per cubic meter per second. Let's try some problems. So a rocket engine in figure E1.1, this is the figure, no? Ito nasa baba. Burns a stoichiometric mixture of fuel. Pag sinabing stoichiometric stoichiometric mixture, ano yan, kumbaga, according to its stoichiometric ratio, walang excess, walang limiting, no? Sakto. So we have liquid hydrogen in oxidant, liquid oxygen. Yung fuel is liquid hydrogen, tapos yung oxidant niya is liquid oxygen. So basically, the reaction is hydrogen plus oxygen will produce water. Ano? The combustion chamber is, this is a rocket engine, ano? Pumunta sa outer space. Si Elon Musk, ano? The combustion chamber is cylindrical, 75 centimeter long, and 60 centimeter in diameter. And the combustion process produces 108 kilogram per second of exhaust gases. So if combustion is complete, find the rate of reaction of hydrogen and oxygen. Okay? So yung rate ng reaction ng hydrogen at saka ng oxygen, dapat ang unit niyan ay moles of hydrogen per meter cube, no, per second. So that's why this is the size of the reactor. Ito yung dito manggagaling yung cubic meter, no? Yung meter cube. Ito manggagaling yan. Kung 70, i-convert niyan sa meter. So 70 times 10 to the minus 2. Yan yung kanyang diameter. This is the length. This is the diameter. The diameter is 60 centimeters. Dito manggagaling yan, no? Tapos itong 108 kg per second, water to. You have your 108 kg of water. So kailangan niyo siyang i-convert sa kilogram mole, tapos convert niyo sa mole, ano, times 1,000. Tapos you need the balance reaction para makalculate niyo yung rate ng production ng hydrogen. Yung needed hydrogen at saka yung needed oxygen. Imagine niyo ba? So halimbawa, no, you have 108 kg per second of exhaust gases. This is water, no? So if you have 108 kg of water per second. So, di ba ang water 18, ano? Di ba nyo lang ito ng 18 kg of water is equivalent to 1 kg mole, di ba? Tama? So this is, if you're going to use your calculator, you're going to get 6. No? So, ang production ng water is 6 kg mole per second. So, halimbawa, meron kayong 6 moles of water as product ng combustion. So, how many moles of hydrogen and how many moles of oxygen do you need? So, balance nyo lang to. So, kita nyo naman to, 6H2, ano? So, ito is 6 nyo to. Tapos yung oxygen ay ilan? So, you need 6 oxygen tapos divided by 2, you need 3. The oxygen. So parang ito yung balance reaction, ano? So basically, halimbawa sa hydrogen, you're going to produce, kasi di ba 1:1 siya ng water, ano? So you need 6 kg mole of hydrogen, ano? Tama? Na-imagine nyo? You need 6 kg mole of hydrogen. So times 1,000 kasi kilogram mole yan. Ibig sabihin, you need 6,000 mole of hydrogen. This is per second, ano? Per second. Ganun lang yan. And then basically you need to calculate the area of the reactor. So ano bang formula ng cylinder? Anong volume ng cylinder? Pi d squared over 4 times the length. No? So substitute mo lang dito yan. Pi. Ito yung diameter niya. No? So 60 times 10 to the minus 2. So this is in meter na. No? Squared nyo to. Don't forget the divided by 4. Tapos multiply nyo siya ng length. The length is 75 times 10 to the minus 2. This is also in meter. So using your calculator, ilan yung volume ng ating reactor. Kaninang umaga kasi. Naano nyo rin ba yun? Kaninang umaga kasi biglang may lumabas sa MCL page niya. Sa 5 pa daw yung start ng classes. Kaya medyo times 60 exponent minus 2. Ano? Tapos you just square this. Try to get your calculator. Tapos you divide this by 4. Tapos you multiply this by 75 exponent minus 2. Yung minus 2 galing yun sa centimeter, di ba? Centi. Centi is minus 2. 10 to the minus 2. You're supposed to get something 0.2121, di ba? Cubic meter. That's the volume of the reactor. 0.2121 cubic meter. So pag diniban niyo yan dito sa, kasi di ba yung unit natin is mole per cubic meter per second. So didivide niyo lamang dito yan. Ano? Divide niyo itong 6,000 ng 0.2121 cubic meter. You're going to get the rate of hydrogen, no, burn in the rocket. 6,000 divided by 0.2121. You're supposed to get 28, no, 28,000, mga ganun na lang. 28,288. Get? Do we have the same answer? 0.212. Yes, the area is 0.212. And then this will give you 28,000. Ano? 28,288. So this is in mole of hydrogen per cubic meter per second. What about oxygen? So kita niyo yung oxygen, half nung hydrogen, ano? So i-divide niyo lamang ng 2. So divided by 2, you're supposed to get 14. 14, 1, 4. Mga ganyan, ano? Mole of oxygen per cubic meter per second. Ganyang kabilis yung rate of reaction sa jet engine. Ano? Ito, sorry. This is rocket engine. Kailangan niyan pag may comet. Pag may aasa sa Amerika yung grabe yung China tsaka sa Russia nag-fail Sa United Nations nag-fail yung rocket nila. Sunog. Pero yun ang don't look up. Yun. So, do you have any question regarding this solution? Tama ba? Compare natin sa sagot sa libro. 28,000. This is 28,000. Ano? And then this is 14,000. Ganong kabilis. Yung 6,000, galing yun sa 6 kg mole per hour. Itong 6,000 na to, galing siya dito. Di ba this is water? Di ba yung water at saka yung hydrogen, parehas lamang yung rate nila, magkabaliktad lang ng sign. You are producing water but you are consuming hydrogen. So the absolute rate is 6,000. Kasi kilogram mole to eh. So this is per mole. So times 1,000. Doon galing yun. So that's why yung level pag sa rocket engine mga at this 1,000 of mole. Tingnan nyo dito. Sa ating 1,000 of mole. Yan dito yan. 10 to the 4. Up. 10 to the 10,000. This is not only 1,000 to the 10,000 siya. Ganun kabilis yung reaction sa rocket engines. Dito sa level na to. Dapat mabilis. Siyempre, para makalabas siya ng Earth's gravitational pull. Kailangan ganyan. Yung mga plane hindi makakaabot hindi siya makakalabas. Lang yun, paikot-ikot lang siya din sa taas. Hindi totally mawawala yung pull sa kanya ng gravity. Hindi yan makakalabas. Kasi ito lang yun eh. Ito lang yung kanyang rate of reaction. Dapat makaabot ka ng ganito para rocket engine siya. Let's try to solve more problem. Do you have any question regarding this one? Ito naman, sa naman natin, sa body natin, mga nagdadalo. Ano ba kayong nag-gain na weight sa Christmas season, vacation. Yan, tinuturo sa amin sa biochem. Kahit anong kainin mo, tataba ka. Pare-parehas lang naman yan. Lahat yan nagiging acetyl-CoA. Anyway, magbabiochem kayo later. Hindi totoo yung no rice diet, no rice diet. Pare-parehas lang yan. Kahit anong kainin mo, kumain ka ng taba, kumain ka ng protein, kumain ka ng carbohydrates. Lahat yan magiging acetyl-CoA. Tapos yung acetyl-CoA, lahat yan magiging fats. So tataba ka kahit ano bang kainin. Mamili-mili ka pa ng kakainin. Hindi totoo yun. Kahit anong kainin mo, basta marami kang kinain, tataba ka. That's the truth. Anyway, let's go. A human being, 75 kilogram, consumes about 6,000 kilojoules of food per day. Assume that the food is all glucose and that the overall reaction is, this is C6H12O6 is glucose, ano? Plus 6 CO2 from air. It produces 6 carbon dioxide plus 6 moles of water. You breathe out carbon dioxide, of course. And then the delta H of the reaction is 2,816 kilojoules. No? So this is, siyempre, this is per mole ito, no? Per mole of glucose. Ano pa ba yun? Pati yung ano, halimbawa lumaki yung tiyan mo, hindi rin daw nakukuha, gusto mong palitin yung tiyan mo, hindi rin daw nakukuha yung sa exercise. Kasi pag nag-exercise ka, kahit halimbawa yung exercise mo, yung ano, yung nagsi-sit up ka, di ba, pampaliit yun, iniisip mo pampaliit ng tiyan yun. Hindi din daw kukuha yung system mo ng fats sa tiyan mo. So, kukuha siya all over your body. So, hindi, kung gusto mo talagang magpapayat, ang paliit ng tiyan, kailangan mo talagang mag-diet at saka mag-exercise na sabay. You get what I'm trying to say? What I'm trying to say is, kahit na ang exercise mo, nagsi-sit up ka, and then because you like your belly to be smaller, hindi rin daw mangyayari yon. Kasi kukuha yung system mo ng fats all over your body kahit na sit up yung ginagawa mong exercise. hindi mo matatarget na dito lang siya kukuha ng energy sa tiyan mo. No? It will consume energy from all over your body. And anyway, let's try to solve it. So find the man's metabolic rate, the rate of living, loving, and lapping in terms of moles of oxygen used per cubic meter of person per second. So yun pa rin yung unit natin, ano? Moles of oxygen used per cubic meter of person per second. Okay, so paano yan? Ang binigay na unit ay 75 kilogram. Pang mga Amerikano yan, ano? Tayo naman, hindi naman tayo maabot ng ganyan. Usually mga 50, 60 lang tayo. Yung mga lalaki, yung mga babae nga, much lower. Okay. So how do you convert this 75 kilogram to cubic meter? Yun yung unang problema din. So as engineering student, dapat alam niyo. Ano ba ang natin, composition natin? Sa palagay niyo, anong density natin? Jamila, do you have any idea kung what's our major composition as human? We are, yep, very good, Jamila. We are water. Yes, I think we're around 90% water or more than. Very good, Jamila. So, yung water na yon, 'di ba? Yung water na yun, yung gagamitin nating density to convert that 75 kilogram. No? So ano bang density ng water? 'Di ba? Ang density ng water ay 1 kilogram mass per volume, 'di ba? 1 kilogram per liter. 'Di ba? So ibig sabihin yung 75 kilogram na 'yan ay 75 liters. Tama? Do you agree? So anyway, ganun yung solution sa problem. So 75 kilogram is also 75 liters. So i-divide nyo ng 75 liter, convert nyo lamang yung 75 liters sa cubic meter. Ilang liter sa 1 cubic meter? Adrian. Ilang liter sa 1 cubic meter? Anong conversion? 1 cubic meter is how many liters?
Ano po ulit, sir?
How many liters in 1 cubic meter? Isang drum, ilang litro yung isang drum? Any idea? Anong conversion? How do you convert 1 cubic meter to 1 liter?
1,000 po, sir.
Very good. 1,000 ano? So ganun lang, ba? We have 75 liters. Divide nyo lang ng 1,000 yun. That's your cubic meter. No? That's the number of cubic meter. So 0.0075. Anyway, just use your calculator. Tapos this is 2,816 kilojoules. So ilang moles ng ilang moles ng glucose yung mako-consume? No? Remember, 1 mole of glucose, 180 yan eh. No? The 2,000, itong 6,000, divide nyo lang ng 2,816, that will be the number of moles of glucose. This is 180 grams. So mga ganun. Ano? That's how to find the... So if you divide 6,000 with 2,816, you will find the number of moles of glucose. Pero for every mole of glucose, you will need 6 moles of oxygen. So i-multiply nyo lamang yun ng 6, no? You will have the number of moles of oxygen. So this is per day. So yung 1 day, kailangan yung i-convert yan sa per second. Tapos divide yun ng 75 liters divided by 1,000 liters per cubic meter. You got the idea? So you can after that you can find the rate of the reaction in moles of oxygen, no, per cubic meter per person, per cubic meter of person per second. Okay, so yun. Earlier we have, using the density of water, we have found that this is also equivalent to 75 liters, ano? And then this is equivalent to 75 divided by 1,000 cubic meter. Question? Yan, nandito ako. Okay. So tapos ito yung 6,000 kilojoules divided by 2,816. Ito kasi 2,816 kilojoules per mole. Per mole of glucose yan. This is glucose. Yan. Tapos for every mole of glucose, you will need 6 moles of oxygen, ano? So times 6 moles of oxygen per mole of glucose. Okay lang? Do you have any question regarding the units? So itong sagot dito, you just simply divide it by dun sa cubic meter. Did you get the solution? Sige nga, what's the answer? We get the solution. So 6,000 times 6. Pero this is per day pa lang, ano? Makalimutan nyo, per day pa lang yan. 2,816. Tapos times 75 divided by. You're supposed to get something like 170.45. Ano? Pero per day yun. Divide natin to. Are you with me? Nakakasunod pa ba? So this is, ang unit nito ay mole per day, per cubic meter per day. Tapos, yung per day, so 1 day is how many hours? 4. Tapos, yung hours, how many seconds? 1 hour is 3,600 seconds. So, ano yung final answer? Divided by 24 divided by 3,600. So, anong rate ng reaction natin? Nasa? Any answer? I'm getting something like 1.97 times 10 to the minus 3. Do you have any question? Asgard. Mole of oxygen per cubic meter per second. Yep, very good, Gio. Ano? 1.97 times 10 to the minus 3 mole of oxygen per cubic meter per second. So ganun kabagal yung reaction sa sa atin, no? Sa body natin. As compared dun sa rocket. 'Di ba yung rocket kanina nasa 28,000, no? moles of hydrogen. Di ba? Tandaan niyo pa yung kanina, 28,000 moles of hydrogen per cubic meter per second. Sa atin, no, yung kakain tayo, tapos i-burn natin yung i-burn natin yung kinain natin. So yun, ganyan lang kabagal siya mag-burn. 1.97 times 10 to the minus 3 oxygen per cubic meter per second. Yung ba, rocket na lang kayo para hindi kayo tumatama. Mabagal, 1.97 times 10 to the minus 3. Balikan natin yung yung chart. Nakuha naman yung calculation. Simple lang naman yung calculation, di ba? Yan. Ito kanina yung rocket natin, ito yung cellular reaction, 10 to the minus 3. Ganyan kabagal. 10 to the minus 3, tapos yung sa rocket, 10 to the 4. You have any question? Regarding these problems? That's man's metabolic rate, the rate of eating, loving, and laughing. Nice book. Actually, this one, ito, Levenspiel at saka Pagler, they are both nice. They are readable, very readable. Ewan ko ba naman sa boards natin, hindi nila,
God of Fortitude.
Bannes is also very good, pero
God of Fortitude.
these two books are more
Same
readable
pattern.
than Bannes. Okay, so, ayun, 0.002. This is also the same as 1.97 times 10 to the minus 3, Question? So this is, hindi na to example problem. Yung problem na at the end of the chapter. The first problem at the end of the chapter.
Midgard.
So this is about municipal waste treatment.
Here.
So consider a water treatment plant for a small community.
City.
So wastewater at 32,000 cubic meter per day flows through the treatment plant with a mean residence time of 8 hours. Kailangan introduce ko muna kayo sa mga basic equation. Yung residence time, ito, advance yung concept niya. Yung residence time, usually ang ginagamit na variable dyan is the tau. No? Kasi time, di ba? T. No? Dapat kasi hindi na Omicron yung pinangalan dun sa dapat Omega na agad eh. Para tapos na Ayan, Omicron, baka may kasunod pa yun. May Omega pa, hindi naman sunod-sunod yung pinapangalan nila. Diba? Delta, tapos biglang naging Omicron. Hindi na lang agad Omega eh. Anyway, going back, pag residence time, ito tau yan. This is equal dun sa volume ng reactor. Okay. Kailangan nyo kasi yung volume ng reactor, as you can see from our previous problem. Yun yung ginagamit natin pan-divide as cubic meter. Divided by flow rate. Flow rate is B. Tandaan nyo pa? Sa 1, 2, 3P. Di ba flow rate itong B? Volumetric flow rate. Tapos yung B, the capital B, this is the volume of the reactor. So, basically, pag given yung residence time, yung 8 hours, tapos given ka nung flow rate na 32,000 cubic meter per day, you can calculate B. Diba? Kasi given itong dalawa. You can calculate B. Ganun lang naman. So, pag may B na kayo, tapos you just, from the other given, you can find the moles per second or moles per day or whatever. You basically just divide that with B. Na makakalculate nyo from residence time and from the volumetric flow rate. Let's read again the problem. Kailangan kasi medyo may konting background. Hindi ko lang alam kung naabot nyo yung rest. Probably hindi rin eh. Pang chem-eng talaga yung residence time na yan. Consider a municipal water treatment plant for a small community. Wastewater, 32,000 cubic meter per day, flows through the treatment plant with a mean residence time of 8 hours. Air is bubbled through the tanks and microbes in the tank attack and break down the organic material. So ganun lamang yung waste treatment plant, hinahalo lamang siya, So habang hinahalo siya, ang tawag doon is the aeration process. Habang hinahalo siya, nag-i-introduce ng oxygen. Oxygen yung agitation. Tapos, because of this oxygen, meron namang bacteria doon, kinakain nila yung mga organic doon sa wastewater. That's how you treat wastewater. No? So organic waste plus oxygen, microbes yung kumakain ng organic waste with oxygen, it will be converted to carbon dioxide and water. So a typical entering feed has a BOD. So BOD is biological oxygen demand. I don't know kung meron kung kumuha na kayo ng wastewater. Anyway, biological oxygen demand of 200 mg of oxygen per liter. Basically, this is the amount of oxygen needed to react with the organic waste. Yan yun. You need 200 mg of oxygen per liter. While the effluent has negligible BOD. So dapat paglabas doon, treated na siya. Wala na siyang organic. Pwede niyo na siyang itapon sa ilog kasi wala na siyang organic. Find the rate of reaction or decrease in BOD in the treatment tanks. So from 200 to 0. No? So actually conversion lang naman yan. Kasi di ba, ang unit natin palaging moles of oxygen, gagawin nating moles yun, yung 200 mg per liter, gagawin nating moles of oxygen per second, no? Per second per cubic meter. So di-divide natin nung B. Okay, so meron tayo ditong yung concentration, yung BOD natin is 200 mg per liter, tapos we are using 32,000 cubic meter per day. Okay? Yung output natin, yung product natin, zero yung BOD. So all of this 200 mg of oxygen is consumed. Okay, so palaging tatandaan, ang unit palagi ng rate of reaction ay mole of oxygen per cubic meter per second. Yung palagi ang rate na hinahanap natin. Okay, so dito muna tayo, calculate muna natin yung D. So ang ating residence time ay 8 hours. Tapos yung volume natin, yun yung hinahanap natin. Ang flow rate natin ay 32,000 cubic meter per day. So you need to do some conversion, kasi this is hour, this is day. So how do we convert this in day? 24 hours lang, 1 day is 24 hours. So yun, cross multiplication. So anong value ng volume? Ano yung volume ng reactor? So 8 times 32,000. Get your calculator, divided by 24. Meron kayo mag-cross multiplication, di ba? Cash, solve nyo. Ilan nakuha nyo? Anong volume na reactor? $10,000. Yep, very good. John Paolo, Gio, Jamila, very good. 10,667, very good. So this is in, ano bang unit natin? Cubic meter, 10,667 cubic meter. Yan yung pang-divide nyo mamaya doon sa i-divide nyo yung mole O2 per second. Okay, so dito naman tayo sa mole O2 per second. You have 200, conversion 200, yung milligram, anong milli? Times 10 to the minus 3, di ba? Gram, oxygen. So gram na to, tapos per liter yan. Ito yon. Okay. Tapos you have 32,000 cubic meter per day. So you just multiply this by 32,000 cubic meter per day. Okay, ang objective natin is we need to convert this to mole of O2 per second. So ito muna, dapat mag-cancel out yung liters na yan, tsaka itong cubic meter. So convert natin yung cubic meter. There are 1,000 liters per cubic meter. Cancel to, Yun. So tapos cancel din yung liters. So yun na, gram of oxygen per day naman. Yung day naman, yung day. So gawin natin siyang second. So 1 day, kamukha nung kanina, 24 hours. Tapos 1 hour, 3,600 seconds. So grams per ano na siya, grams per second na. What about grams, O2? How do we convert that to mole? Anong molar mass ng oxygen? 16, 16. So 16 ang O, di ba? So 32. Ano, dapat memorize yan, ha? Kailangan memorize yung molar mass ng oxygen, carbon, nitrogen, mga common yan. Although sa handbook meron namang periodic table. Dati kasi pinatatakpan yun eh. Ewan ko lang ngayon. Paano man hindi na. So 32 ano? 32 ang oxygen. So divided by 32 grams O2 per mole O2. Magka-cancel to. Wala na. No? So mole O2 per second na yan. So just dapat tama pindot nyo sa calculator. Tapos i-divide nyo nung 10,667. This is sa wastewater. Ano? 200 exponent minus 3. Be careful sa pagpindot sa calculator. Times 32,000. Okay, times 1,000. Yun munang nasa numerator. Tapos yung sa denominator naman, 24 times 3,600 times 32. So, you're supposed to get 125 divided by 54. 2.31. You're getting 2.31. Dito pa lang. 2.31. No? 2.31. This is mole O2 per second. So, pag dinivide siya ng 10,667, okay, so divided by 10,667 cubic meter. So, ang final answer ay parang ano rin kasi to, mabagal din siya, ano? Kasi biological din yan eh. So, parang halos ka-level din siya nung sa body, no? I'm getting 2.17. I'm getting 2.17 times 10 to the minus 2. So this is mole oxygen per cubic meter per second. You getting this? Ano ba? Do you have any question? Ayun, 2.17 times 10 to the minus 4. Ang Levenspiel ay merong solutions manual. So hanapin niyo yung ebook ni Levenspiel tapos Google niyo lang. That is a very popular book. Pati yung solutions manual niya madali din lang hanapin. So hanapin niyo yung dalawa, ha? Ito yung sagot. 2.17 times 10 to the minus 4. So kasi biological din to, biochemical din, ano? So we're going to go back dun sa chart. Andun din lang yun. Katabi lang siya nung cellular reaction in industrial water. Ito yung 10 to the 4. Ito yung sa human, di ba? Magkakatabi lang yun dyan. Kasi parehas lang naman sila ng nature. As opposed dun sa mga industrial process like rocket engines na 10 to the 4. No? Do you have any question? Any question regarding our last problem for today? Yan. Tatanungin niyo ako. Dati nung nag-PBR kami, yung PBR kasi, yung PBR, yeah, we were using polymath. Yung polymath software actually pang solve siya ng differential equation. 2019, mga February of 2019 na nagwa 172 kami. So sinisingit yung mga sample problem kasi doon kayang-kaya niya yung epidemic. Ang epidemic kasi differential equation din lang. So tinatry namin i-simulate yan. Nakikita namin kahit isang Chinese lang na mayroong COVID yung pumunta sa Pilipinas, ganyan talaga yung mangyayari. So hindi mo rin talaga may iwasan mangyayari at mangyayari talaga siya. So pati kung kailan siya magpipik, ang dali-dali lang yung i-predict yung mga ginagawa ng Okta. Kayang-kaya ng polymath yun. Actually kahit manual, hindi nga lang ganun talagang ka-eksakto. Pero kayang-kaya ng polymath i-predict kung kailan magpipik, kung saan, kung ilang araw. The sad thing is exponential yan. Exponential. Kaya, di ba, 200 lang, tapos biglang 4,000. Tingnan nyo mamaya kung ilan yung bilang mamaya. Taas ata yung reproduction ratio ngayon. Bakit ano? Eh, nagkakaubusan na ng pages. Ewan ko lang kung ano lang yun. Kung totoo yun or chismis lang. Ang oras na. Do you have any question? 4:07. 7 minutes. So, hindi ko na lang i-check yung attendance niya. Ano? Kasi 4:07. Anyway, recorded naman to. Yung mga hindi naka-attend, sabihin nyo lang, manood na lang sila ng video. Ano? So, ang gawin nyo guys, maghanap ka, i-google nyo yung Levenspiel. You get the ebook. It's very readable. Ano? And then you get the solutions manual. Tapos try to solve the problem on the end of the chapter. Konti-konti lang naman yan. Hindi siya nakakasawang isolve. Tapos maganda yung problem. Promise. So, that's how we enjoy chemical engineering. No? Siyempre, nagbabago ang panahon. Pero maganda pa rin naman siya. It's very relevant. Yung mga ginagawa ng Okta, kayang-kayang gawin. Nagagawa namin, sabi ko naman sa inyo nung February of 2000. Is it 20? Ano? February 2020. February 2020. Napipredict namin yung ano. Na magpitik din talaga sa Pilipinas ng ganyan. Differential equation lang yun. But anyway, so see you again on Thursday and then try to download the books, ano, yung solutions manual, yung Levenspiel, at saka yung ebook mismo ng Levenspiel. So, hanggang dito na lang muna, ano? Natataw. Levenspiel. Dayan. Leven, tapos Spiel. Yung isang kaklase, yung isang kabatch ng college, yung mga anak niya, meron siyang isang anak ang pangalan Levenspiel. Anyway, later we'll shift to Pagler. Huh? Ganyan. Chemical reaction engineering by Levenspiel. And any other question? Any other concern? So medyo nag-overtime ako, pasensya na. Kasi kanina may post na January 5 pa daw yung klase. Kaya medyo nalito rin kami. Pasensya na kung medyo na-late ako. Anyway, yun. Mahirap naman kasi bombayin kayo na masyadong maraming information in a session. Masakit din sa ulo. So, yan muna. At least naka-isang chapter tayo. No? Next meeting, subukan natin makadalawa kung kaya natin. And then, relax muna. Huwag kayo magpapasakit. Huwag muna kayo nahalo sa maraming tao. Nakita ko nung Pasko, nung New Year. Diyos ko, grabe. Parang walang COVID sa Pilipinas. Ang haba ng pila kahit saan ka pumunta. Tapos siksikan talaga. Kahit saan. Ganun din ba? Na-observe nyo rin ba dyan sa Santa Rosa, sa Calamba? Eh dito nga sa amin, bari-bari. Diyos ko, ang dami talagang tao. Patakot. Para naman, hindi matuloy, hindi mag-explode yung cases. Okay. So, sige. See you on Thursday. Bye-bye na muna.